Hi all, welcome to a tutorial set on the R programming language. So this tutorial set is not going to focus from a base level, but it's going to look at some of the more common concepts used in data analytics and statistical analysis. So a couple of books I'm focusing on, so I'm going to, as I've probably told you a couple of times, this is one of the books that I use to really understand R programming from the offset. So this has got loads of little exercises and little notes to look through, so I highly recommend this. So it's R for data analytics in easy steps. That's going to show you really more of the basics, but also if you get stuck, you're going to be able to go back to it and go, this syntax does this, etc. Okay, and then all the individual tutorials I do and some of the references I make are going to come from this book, so the EMC Data Science and Big Data Analytics book. So I'm going to do some more videos which look at the theory, which is going to cover some of the theoretical concepts of data analytics, but I'm going to focus on going through chapter by chapter based upon the practical elements as well. So this first video is going to focus on an introduction to the R programming language, but like I say, not from a base level, but from a level of concepts looking at data analytics tasks. Okay, so hopefully if you've done a bit of knowledge already up to this point on the R programming language, some of it you'll find pretty easy, but it's always good to follow along with other people just to make sure you're getting the syntax right, and you might learn some things as well. We're going to have a look at going over how to use the help and demo tools within R programming itself. We're going to look at assigning values, looking at the value types, creating vectors, creating a data frame to store some vectors, looking at loops and functions, creating a user-defined function, replacing some missing values, loading a CSV file to read and use, manipulating some of the data frames within the R programming language itself, and then saving a data set, whether that's in a new data frame or also in a new CSV file. And then we're going to look at some of the base investigation techniques, just some of the simple ones just to get you started. And then subsequently, videos after this should then look into some of the more complex elements, such as k-means testing and regression testing, linear testing, all that sort of stuff. Okay, but if we get a quick base knowledge now of all the different things that we might be doing, then I don't have to go over these in other videos, and then it should help you as well along the way. Okay, so let's get started. Okay, so for this video you just need to load up RStudio. So I'm just going to open a new RStudio here, and you'll see this screen appear generally when you open up a brand new project. So on the left hand side you'll have your console, which means we can type some code into here, for instance. So we could put print, print me, and then enter, and then it'll print just underneath like here. We're going to use our scripts to do our coding, which is like another file within inside RStudio. But this is just in case you can print things to test it and do little commands. On the right hand side you've got the environment where we can load up different sets of data, which we're going to be doing throughout this. In the bottom right hand corner you've got your file systems, and you've also got plots and packages and help and different viewers for different the plots are for different like graphs and things, but we'll get into that in a lot more detail when we go through it. Okay, so what I need you to do is I need you to go to File, New File, and go to R script for me, and then at the top here you'll see a new script, and then go to File, Save As, and then I want you to save it as R Studio Tutorial 1. Okay, save it as whatever you like, but I'm going to save it as RStudio Tutorial 1. Okay, so now you'll see here, if we type some code in, it goes to red, and if we press Ctrl and S to save, it'll then save it and it goes back, and then we get rid of it, and then Ctrl S again. Okay, so two of the important commands we can start off with is you can press hashtag for comments, and that just means that anything that's in comments won't be used within the code when we read it. I'm just going to put helpful tips. I like to do stuff like this just to make sure I can separate my code. So especially for stuff like tutorials when you're learning how to begin with, it's a good idea to separate your code so you can come back to it and you can understand it from a distance. So I like that. So if you type in help and then open brackets, close brackets, and then on the second line put help.start, open brackets, close brackets, And what this does is, if you hover over help, open right scroll brackets, and then you press Control and Enter, you'll see in the bottom right hand corner it's opened up the help section for us. Okay, and then press Control Enter on the second line, it starts it within the console at the bottom. So you can open it up here for help, and then the open up help start will then run it in here. Okay, so like I said, help start, if nothing happens, you should open this link. So if you've not got anything up here, you can just click on that and then that would work. So the other thing you can do is you can ask it to run a little demo for you. So you can do demo, open argument, and then we can do demo, and we could do a graphics version. So these are two different things. So we've got Control Enter again to run. So this will open a new R script, which has got loads of different things for you to have a look at to help. Loads of different ways in showing what RStudio can do. So it's helpful to come back and back to. And then we've got a graphical version. So we could, within this, press, just delete it, demo and then graphics in, and it will start at the bottom within the console. Type return to start, press enter, and then it will go through different things with you, and you can enter it, and it will show you like different graphs and stuff. Which is quite a nice little handy thing at the start to look through. Okay, and then you press escape, and it will escape out of that. So there are two things that I just wanted to quickly show you at the start, just to help you along the way. Okay, so what I would generally do within my code is, for instance, in help star here, I would put opens up the help panel. Seems very simple, but if you're doing stuff like that to start off with, when you get to the more complicated code, you might type something in one day and then you'll understand it perfectly, and then if you put a comment on it, which you can then explain to yourself basically, or explain to someone else that's working with the file, and then they can have a look at it and it'll help them out as well. So it's a good habit to get into from the start. So again, with this command, a series of demos will be shown. Okay, I'm not going to comment all my code as I go through like this every single time, but I'm going to, as well as uploading this video, I'm going to provide the source code as well, and that's going to be a lot more detailed. Okay, so it's going to have a lot more comments on it for you, so you can go back and forth. But for this, it's just a case of getting you into a habit of doing certain things. So let's start off by assigning values. So assigning a value is basically looking at a variable. So we give it a name. So in our case, we're going to use n, and we're going to give it a value. We're going to give that variable that we've created a value. Okay. So we will use n is equal to 10. Within our program in itself, you can do n left arrow hyphen 10. You can do these two different things. For my videos, I'm going to stick to n equals 10 because I think it's an easy way to learn at the start, and also some of the other programming languages generally use this convention. So what this means is that, let's put a bit of space to show you. If you press Control and Enter again, so you execute that statement, so if you execute it, that's what we're going to refer to it as now. Execute it, at the bottom you'll see n is now equal to 10. And if I put n on its own, that means show whatever's in that value. So n is equal to 10, execute, n, execute, and then at the bottom in the console here you'll see n is equal to 10 and then n, and then it'll print out whatever's in n. So in this case it's 10. Okay. If I was to then put in this one 14 and I'll put n, so execute that, n is now equal to 14, and then again execute it and it'll give me 14. So these two different ways of doing it. The reason that it's got two different methods like that is this is like a standard way of doing a lot of programming languages and assigning values to different elements. So n equals 10 is equal to, it's quite simple. But some of the more complicated data frames and elements you will do later on generally use this because it's assigned to that value. So you've got the n on the left hand side and then the arrow pointing towards it, that number is then assigned to that, and it looks a bit clearer and it looks a bit more helpful because some of the obviously programming you do, it could be complex, and if you can see where variables are going, it can be quite useful. Okay, so for instance, so in here this assigns the value of 10 to n. okay? And then when we put a variable just on its own, then it just displays the value of n. Okay, so a bit more complicated. We could put n is equal to 10 plus 2. We can give it little sums to work out as well. And then again, display n. So execute, so it tells you the command at the bottom, and then we do it again and it gives 12, okay? So these are a couple of really simple assigning values techniques that you use continuously throughout our programming and programming in general, okay? So, moving on. Now we're going to look at value types. So a type is something that's connected to a variable which defines what's going to be within that variable. So for instance, we could have numeric, or we could have a string which is text, or we could have a boolean, or we could have a float. There's lots of different types of data that we can assign to a variable. The reason we specify the type of variable is so that when we're looking at memory and we're allocating elements of memory to that particular variable, it can allocate the right amount of memory space to allow that variable to live within it, okay? That means that programs generally run faster and they're more optimized, so it's really important to get right. It also is very useful when we're coming to working with different types of data, because it allows the actual specification of the variable to be shown, and then it knows how to work with it. So if we were adding, for instance, two strings together, that might not work the same as adding two numeric numbers together. So it's good to identify from the start what's in that data, okay? So a couple of, again, quick ones. So x equal to 1, just like we have done on above there, and then a is equal to elephant, okay? So all we've done here, we've assigned two different values, a numeric one to x and a string version to a, okay? Then we're going to put together some mode functions to display these types of variables. So we could, like you said, we could just put a, or we could just put x, but generally you wouldn't do that because that's a quick way, but it's not doing anything with the data. So in this case, what we're going to do is we're going to look at putting it within an argument. So we could put mode, and then inside the argument we're going to put the value of whatever's in x, okay? And then again, inside mode we're going to put the value of whatever's in a. So if we execute them two commands now, so x is equal to 1, a is equal to elephant, and then we run mode and it tells us it's a numeric, and if we run, I put a 1 there for some reason, and if we run mode a, it tells us it's a character. So using mode itself, it tells us what type of variable is within that save. So this can be really useful moving forward. These are just a couple of the quick things that you would use a lot, but it's just good to make sure you definitely understand what they mean from this point. So one thing you can do on the bottom as well is you can press Ctrl and L, and that'll just delete your console and it'll make it easier for you to see, okay? So we've had a quick look at value types and assigning values, and now we're going to look at creating a simple vector. Again, we're going to skip over quite a lot of these mini topics just because we need to get into the more data analytics aspects and the more complicated stuff, and this just means that you can have a quick refresher and then you can go back to the books that we provided and have a look at to go over the topics in more detail. So within this we're going to create 3 different vectors. The first one we're going to call numeric, so numeric is equal to C, and then inside we'll put 2, 3, 4. The second one is string is equal to C, and then we'll put 3 sets of strings within this. We'll put AA, BB and CC, doesn't really matter what you put. And then finally we'll put a boolean, C, and we'll call true, false, and true. And then after we've stored them numbers, or them vectors, we will want to display the numeric, the string, and the boolean. So you've got three different ones here. The first one is called numeric, but it doesn't have to be called numeric, it can be called anything. It stores the values of 2, 3, 4. The next one is a string, again can be called whatever you want. It's going to store A, B, B, C, C. And then a boolean is going to store a true or false statement. It can be sometimes referred to as a flag on and off, or it can be referred to as a switch, but in this case it's just a boolean and true, false, true. And then if we execute these three commands like so, it will store them data, and then we execute the next three and that will show whatever's in that vector onto our console window. Okay, so again we'll just do Control-N to get rid of that screen. It's not actually getting rid of whatever's stored in the variables and the vectors, but it's just clearing it so we can see it easier. So we've created three simple vectors, and now we're going to create a data frame. Okay, so creation of data frame. So a data frame in essence is a collection of vectors of equal lengths, and it's looked at. It's a way of showing different vectors together. Okay, so we're going to create a data frame. So df, again we can call it whatever we want, is equal to data.frame. So this is where you're giving it a command. We want to create a data frame, and inside that we want to show the n, s, and b. Okay, so we want it to show three different arguments. Okay, we've not called it n, s, and b. Numeric, string, and boolean. Okay, so it wants to use these three different vectors. So you see now it's created here a data frame with three different objects. In the top right hand corner here you'll see it says three objects of three different variables, and if we click on that it will take us to that data frame screen, and it will show us a numeric, string, and boolean that we've created, and also the lists are 1, 2, and 3. Okay, so we just nip back to it. So we'll nip back to that other file we're working on, and then we just put df here, and we run this as well. It will then show within the console window that same data frame we've just created. Data frames themselves are really, really important. So it's a way of collecting data ready for analysis. So all we're doing now is we're looking at structuring data. We're not actually analysing any data yet, but we're looking at structurally how you can put it together, and then how it can be then be used in future to do analysis and look at statistical analysis. Okay, so we've cleared the console again, and we're now going to create a quick loop just to show you how we could then use some of this information. So loop, put loop in function, use a quick function. Within this we're going to do ul is equal to seq, or sequence, of 1 to 10. So basically this is going to create us a quick vector from 1 to 10. So it's going to give us 10 different numbers within it, so we can work with. And then we're going to set up a variable called usq is equal to 0, and then we're going to make our loop. So for is equal to I in 1 to 10, open double brackets, usq is equal to ul I in squared brackets, which means we're looking at it within the array, and to the power of 2 plus usq. Nice and simple. So we've defined ul as a sequence from 1 to 10, so a vector within 1 to 10. We've got a usq to start off with an assignment of 0, so this is another variable which we're going to update within our loop. We're going to do a for loop, which is I is 1 to 10, so when I is in the value of 1 to 10, then continue. If it's not, stop. And then we've got the command, which is usq, which is our variable here, is equal to this when I is between 1 and 10 to the power of 2 plus USQ. So what it's going to basically do is it's going to run 10 different times. So I here, I, it's going to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 within here. It's going to then, whatever number is stored within this USQ at that time, so if it runs once, then it's going to be the value of I to the power of 2 plus 0. The second time it runs, it's going to be I to the power of 2 plus whatever numbers previously was in the USQ, and then so on 10 times. And then it's going to print out a list of variables, a list of values for us, okay? Which you'll see when we run it a little bit better, I think. So again, execute as we go along to USQ, and then I have done the equals in the wrong place. There you go. Why did it run differently? It shouldn't have done anyway. I think it's because did I highlight something by mistake? Yeah, I highlighted something by mistake. There's another good quick tip. If you highlight something like that, it's gonna execute that small little part of that command. So it's going to execute the equals sequence, and that doesn't work. So you need to go to the end of the line, or just click on the line. And if you execute that line, it'll say U is equal to sequence 1 to 10, and then USQ is equal to 0. Then it's going to run the for loop in the first line, and it's going to run like that. So the final total is 385 because it's ran 10 times. It's added up the value plus 2 every single time, and then squared it. And then from that, it gives us the value of 385. So it's a very useful thing, this, when we get into data analytics, to run certain commands and certain instructions over and over again to get different sets of data based on conditions, okay? So we're going to skip ahead again. So now we've looked at user-defined functions briefly, we're going to look at replacing missing values within data. Okay, so obviously replacing missing values is really, really important when we're using big parts of data, or it's not just replacing them, it's looking at where that data is and looking at how we can then how we can modify that data to what we need. So we're going to do just a couple of little commands just so you can see how we could do it. Replacing missing values. So in order to do this, we're going to create our data frame. So we're going to put data fm is equal to data.frame, 3 vectors within this. One of them is C, which is 1, 2, 3. The second one is we're going to put NA6 NA, and then in the third one we're going to put we'll put test inside speech marks. The string we'll put NA, and we'll put replace inside a string as well. Okay, and then we'll do string as factors. So this basically means that it should convert the characters to factors, to strings, and then we're going to call that false. Okay, took a while. So basically what this line's doing is it's going to create a data frame with 3 different vectors within it called data fm. So we can then execute that command and it will execute it at the bottom. Then we're going to do column names within the data fm, and we're going to assign them to the values of 3 different strings, and we're going to call them col1, col2 and col3. Okay, so 3 different columns such as that. Within the data fm itself, up here, if you click on it, the columns themselves aren't named like that. They're just based upon what the functions, what's within the variables themselves, so NA6, NA test, NA replace, test, NA replace. So all this does is it's going to allow us to rename them to make it easier for us to understand and use them. Okay, so I've not done it right because unusual argument. What have I typed out wrong? I've not put a bracket around the variable itself. So the column name data FM is equal to C within that variable, and then 1 brackets. Okay, and then that's now changed to our data FM, and it's give it to titles 1, 2, and 3 like so. Then we can again show that to the console. Data FM. You can, if you type it right, you can show it to the console. We can have a look at within this data frame we've created. Is there any NA data FM? And this is basically asking the question: is there anything that says NA within it? NA is like a common term used within our programming when you're importing stuff to look at the gaps, and then it assigns NA to that gap. In this case, it's going to come back as a boolean, so it's going to come back as true or false. This is good, but it can be better. So we're going to do column sums, and then again is NA within our variable of data FM. So it's going to have a look at our data frame variable name again, and then it's going to tell us that within column 1 there's none, within column 2 there's 2, and within column 3 there's 3. If you click on the data FM within the environment, you'll see there's none in the first column, there's 2 in the second column, there's 1 in the third column, just as it's said within the column sums statement and instruction. We could create a new data frame here, so we could do data frame FM underscore new to create a new one is equal to na.emit data FM. So we could do this, and what this will do is it will look at our new data FM underscore new, and it will import everything from our data FM without the NA results into our new data FM new, and then it like so. And then if you look in the environment, if you click on it, you'll see there's no data in there. So what that's done is it's looked at data FM, it's found all of the columns, the rows which have got NA within them, and it's omitted them from the new data frame, which is now data frame new, and it's got no results in that because of that. Okay, and then again we could just put data FM underscore new, and that would display that to the console window for us to look at. Okay, we could also, okay, so there's 3 more little things I want to go through within this video. So the next thing we are going to do is we are going to look at loading a CSV file to read and use. Okay, so we're going to look at loading a CSV file, so an Excel file, a common separated value language, into the R programming language in RStudio. We're going to manipulate some of the data within that, and I'm also going to save it as a different file as well. So hopefully you've got a little bit of a process we're going to go through to finish off this tutorial. So a good thing that we can do to start off with is we can do get WD, so get working directory, and that shows us within our RStudio which directory we're working from. So you'll see at the bottom of here I've got C users lead documents. Obviously yours will be slightly different. That means that where your CSV file is saved to, and also where you're going to put stuff afterwards, then it's going to be within that file domain. So we could put set WD, and then within brackets you could put your file directory. So I'm just going to change to the same one just to see like how it would look. So I would go document like that. So this is where I want to use it. I want to use users, Lee, and then documents, and then when we run that, it will now set the working directory to that. If we go down here, and then we've got all these different lines here, we go to files, and then in here we've got to go to working directory. So we click that, and then that will also take us to there as well. you'll obviously see some sample CSV files that I've been using to set this up, which we're going to kind of use now. Okay, and I'll also obviously provide you with the CSV file for this tutorial, just for you to have a quick work through. So we're going to create ourselves a sample CSV, and then what the sample CSV we're going to create is by reading a CSV file, and then inside here it's called insurance underscore sample.csv. Then we're going to go true, and then we're going to go comma, like so. Okay, so what this is doing is it's loading the insurance sample CSV into the project for us to use, and then it's saying is the data true, and also how it's separated within that CSV file. And because it's comma language, we put in comma to show that that's how the CSV file that we're importing is going to be laid out. Okay, so if we run, so we execute that command, and you'll see we've executed now. That if we go to data FM here, it's replaced the NA values with 0. Okay, so these are just little ways of messing around with the data, and then allowing different ways of manipulating the NA data and the missing data within it. Okay, we're obviously going to use these quite a lot in different contexts, but I just thought it was good to go through some of the basics and understanding now. Okay, so what we'll do then is we'll make ourselves a user-defined function, just to explain this little bit in more detail. So we will create a function called square, and we will use the value of whatever is currently in X. We'll open up some nipple brackets, and we'll put string, open brackets, paste, open brackets, and then a string of square of the number, whatever is in the X value that we're going to store up here, and then is X the value again times X. So obviously the square is number times number, and then this way it's just going to show it within a function, which will make a bit more sense in a minute, and it's going to print whatever's in there to screen for us. So firstly, we're going to do I is equal to 1, because we're going to give I a value to start off with, and then we're going to do a quick for loop, and then whatever I is in 1, 10, so we're going to do it 10 times again, and inside them nipple brackets we're going to put square I, and then semicolon, just a command because it's a statement. Okay, so from here we need to execute it, so we've initialized it, and then we're inside our for loop, we run that through, and you'll see now it has done this 10 different times. It started off with 1 because that's the first number we've initialized, so 1 is 1. It's gone up to here, and it's gone square of the number is equal to 1, and it is 1 times 1, which is 1, and then 2 times 2 is 4, 3 times 3, etc. And it's run through 10 different times. If I was to change this number, for instance, to 19 instead, and we did the same thing, it would run up to 19 times, and so on and so on. Okay, you can't play around with it, like you won't break it unless you put stupid amount of numbers in it. So 999, it runs it all the way through, and you'll get your code like this. Okay, so it's this quick. Now again, if it comes up like this, it means a plus, and it's basically showing you the first 200 lines of code, and there's other ways of doing it. Okay, so that's quickly what a function would do, and then how you can incorporate it into a loop, and then how you can use different variables and stuff that you've done so far. Okay, so again, I'm not going over all of the basics. I expect you to have done some of the reading from some different books or some different tutorials, and these are just some of the more common practices within data analytics that you will use a lot more frequently within the R programming language itself. Look to do something else and delete it, we could add a new value to that NA results. So we could do data FM, and then with inside square brackets this time, we could put is NA within data FM equal to 0. So we'll look through it and we'll assign all of our NA results to our 0 result. You will see that it now insurance sample, I haven't put it in there. Okay, so this is quite good because it just allows me to show you exactly what I'll be doing for yours. Sorry, one sec. So here's the one we're going to be using. So I'm going to save this into my working directory, which in this case is my documents here. I have got insurance template there. I spelled insurance wrong, that's why. So inside here, it's insurance. So we're going to run that line there, and then it will now load it, because I'll spell it correctly, into our domain. So we've got sample CSV up here, and if we click on it, you'll see that this is our CSV file that we've uploaded into the RStudio environment. Now, within this, we can look at the data. So obviously a lot of the data analysis stuff you're going to be doing is using real life data rather than that's recorded in things like Excel documents and files, rather than just using numbers that you type in yourself. Okay, so the first thing we can quickly do is we can do head sample CSV, and then we can go n equal to 10. And what this is going to quickly do, it's going to read and display the first 10 lines from the file. Okay, so it's going to look into that CSV file and display the first 10 lines. We can do head sample again CSV, and then we will again look at the 10 values, 10 rows, but this one we will in square brackets put comma 5. And what this will do is it will skip the first 5 of the what's the word of the CSV file. It'll skip the first 5 rows, and then it will then show us it'll read and display the first 10 lines from the file, but only from the 5th column downwards. Okay, so again we'll carry on. So let's do Control and delete the console to make it a bit easier to read. Now we've loaded the CSV files in, what we're going to do is we're going to manipulate some of the data within it. So manipulate data frame in R. Okay. So we're going to create a new sample CSV file, and it's going to be called very new. This is going to be equal to the sample CSV, and then within square brackets we'll put comma 4 to 6. So it's going to have basically the columns from 4 to 6 within our new sample CSV very new environment. And if we run this now, then it will load that into our database, our environment, sorry. And then if we click on that again, you can see it from columns 4 to 6. It's loaded that data ready for us to use. So within this, then we can obviously we will just show it to screen. And I'll keep doing this just because it shows that what you can do within RStudios. We could do a dim of sample. CSV. Just go into new, press enter. And we could run a dim, and what that does is it takes the dimensions of that data frame. So it's got 23 rows and it's got 3 columns within it. Obviously that could be very useful at some points. We can have a look at the type of the data frame itself. So the type of the data frame is a list. We could have a look at what class the data frame is. So again, we can execute that, and it's a data frame because that's what we're doing. And then we could then look a bit more of the data itself, and then we could do a sample again of that. And then when we run a sample in brackets, it will then give us some important data. So it could, for instance, in the first one tell us something to do with the standard deviation and the quartiles. It's going to put categories in the second one, and it's going to tell us, like, because of the sort of data it is, how many of each are within that. And again, it's done the same sort of summary at the end, and it's done the quartile one based upon the cost as well, which is really handy. As a quick glance, just to summarise some of the data. If now we wanted to save this, we could saving dataset. If we were to save this, we could go write.csv, open brackets, and then inside that we could write our data frame that we've created, so sample CSV underscore very new. So this is what we've created, and then we could call it whatever we want the name of our CSV file to be called. So in this case, we're going to put sample CSV save file tutorial or something along those lines, okay? And now when we run this, it will then, this is our working directory. You'll see here at the bottom, it's created a new CSV file for us called sample CSV save file tutorial. So really what it's done is it's allowed us to manipulate some of the data within it, and then it's saved it in a certain format, a CSV format in this case, because then we can pass it back on to where we need it to go, or whatever system we're working with. After we've done that, we can remove the environment from the area. So it's always best to work in an environment which is as limited as possible. So you've got nothing that can go wrong. So we're going to go rm sample CSV very new, and this will in here on the environment when we press enter, we'll get rid of that one. Okay, and now we will quickly delete all of the remaining ones. So we'll do an rm, and within the brackets we'll do data fm underscore new, a sample CSV, and a sample CSV underscore new, and then we'll run that, and then that'll get rid of all of them except sample CSV new, because I didn't put the comma in the right place. So inside here, sample CSV there, and then underscore new, and then command. So it's cleared our environment. So they're just some of the useful things that you could probably do just to allow you to start to work with the environment and start to understand it a little bit more of how it can be used. I just thought this tutorial to start off with is a good way of going through some of the key commands and some of the ones you'll use a lot, and also like looking at the holistic picture of how you could use it. So the final thing we're going to look at is a quick investigation of the data. So we're just going to run a few of the investigating tools that are built in, some of the very basic ones, just to see again how it could be used and kind of complete the cycle. So we'll have a look at investigating the data. I'll put a couple more like little ones into here as well for the text version, but just for the case of this, just want to show you a couple of simple things. So we've got sample CSV is equal to read.csv. Then in speech marks insurance this time, sample.csv, and then again true and comma and speech marks, because it's that sort of file. And basically what this does is it loads the insurance sample CSV into our sample CSV environment. So we click that and you'll see it here, it's loaded up into here. And then what we're going to do is we are going to display it to screen, so you can see that it's connected in that way. It'll show at the bottom there, and then just some quick investigation techniques. I'm not going to type them all out because I've quickly saved them into a file that I was using before, just to make it easier to go through them. So here are some quick examples of what you could do. So you could put the mean of, within sample CSV here, the variable of cost. So inside here we've got cost here, so this variable within here. We could do the mean of that, or we could do the mean of it. We do a standard deviation of it, the quantile structure of it, the sum of it all, the range of it all, the maximum one, or the minimum one. Okay, so we could run from here, and we could run these different commands. And you'll see at the bottom, it's bringing up different sets of quick investigatory techniques that we can use, which are very simple. You could do in Excel, you could do in a calculator, etc. But it's a quick way of getting some of the analysis straight away, just by simply looking at a CSV file. So you could pull the CSV file in, do a couple of mini calculations like this, or set up something that really simple that you can use over and over again. And then it's one of the very quick ways at a base level you can start to analyse data, and then you can start to interpret and look at the business problems. The final thing you could do is you could put QF, and if you run this command, it'll ask you if you want to save. And then in this case, we're going to put no. Okay, so hopefully that's gone through some of the basic elements of R programming, but more focused on data analytics itself, rather than just being R programming and hello world and calculators and stuff. We don't really need that. That's just to get you into the programming language. The different videos that we're going to go forward from now, different tutorials, are going to focus on some of the more complex techniques, such as k-means testing, linear regression, all that sort of stuff. Okay, I'm trying to make these videos offline, so you don't have to have access to some stuff like Apache Hadop and then the green different servers to hold data. Okay, so hopefully it should work like that. If there's anything else you want me to go through while I'm doing it, just let me know and I'll make videos on that as well. Okay, so hopefully it's been helpful. I'm gonna publish this video onto the page along with the CSV file, the basic one for the insurance, and also the actual source code that I've created with comments on, because obviously working from a distance, I think it's good that you've got the actual one that's working in case you struggle and you can't find something, and you can go onto that and you can run it and you can copy the code, etc. Okay, so I'll look forward to seeing you in the next tutorial.